10 times. Wow,
Yeah.
wow, wow. That's a big, big, big increase. And as I understand it, durable execution is very unique to you. Why is that?
The idea is very simple, is that we preserve full state of code execution all the time. If you write code and it just executes, let's say you have a function, it calls a bunch of APIs and it's blocked on some API, and then process which holds this function crashes.
I also heard that OpenAI used you for its business logic code.
The image generation. So every time you generate image using the OpenAI, it uses temporal behind the scenes. Because image generation is orchestration, right? It's not just like one API call, right? There are a lot of API calls which need to happen to generate an image. And temporal is a very good technology to guarantee execution.
Welcome to the Tech Transform podcast, where we have a weekly conversation with people impacting the enterprise tech landscape. My name is Shubhangi Dua, the podcast host, producer, and tech journalist at EM360 Tech, and I will be your host today. In this episode, I am speaking with Maxim Fateev, co-founder and CTO at Temporal Technologies. Temporal is an open source durable execution platform that helps developers build and operate extremely reliable and scalable distributed applications. Today, we are diving into the critical world of building resilient software. We'll explore the power of open source business models and a revolutionary concept called durable execution. This concept enables truly crash-proof execution for your business applications. Essentially, we'll uncover how you can compose your application's complex business logic using regular programming languages, ensuring it runs reliably no matter what. Hi, Maxim. How are you today?
Thanks for having me. I'm great.
Well, I'm so excited to have you on the podcast. So, just before we get started, what is the message you're trying to get across to our audience? Let's set the agenda for today.
I think the main message is that there is this new concept, practically new paradigm called durable execution. And if you're not like using it and don't understand it, you are losing big time because you reinvent that wheel of durable execution yourself, and it's hard. It's like practically going back. Imagine it's kind of similar to not having database. A long time ago, you were reading files, but if you're building a business application right now and somebody says, I'm going to read and write files directly without using SQL database, for example, or NoSQL database, you would be kind of laughed at, right? So I think this durable execution kind of new paradigm and new middleware. So if you're not using it, you're kind of in the same world of reinventing the wheel all the time. And we know that it's mostly about increased productivity, like happiness and increased productivity. So your developers are much, much more effective. We've heard numbers from like 5x to 10x developer productivity increase in certain applications. Okay, not 20%, not 30%, but 5, 10x. And which is exactly what everybody wants, right? Not percent, 10 times, 5 to 10 times.
Oh,
Yes.
Thank you for clarifying that. Wow,
Yeah.
wow. That's a big, big, big increase. And as I understand it, durable execution is very unique to you. Why is that? Like, how did you come up with it?
So it is unique because actually, technically, I invented that. It's not just me; it was a big team. And first time it happened at Amazon. I spent 8.5 years at Amazon. I was tech lead for quite a few backend projects. Initially, Amazon messaging platform, which is pops up. Amazon ran on for a long time. It was well before Kafka was even conceived. And Amazon Simple Queue service, AWS Simple Queue service, used that backend to like it ran on that backend. I still think runs on that backend, at least the same design. And later I was tech lead for the simple workflow service, Amazon SWF, and where this idea came first time kind of about, but it didn't fully kind of was fleshed out. And later at Uber, we built an open source project based on this idea. And later we started the company. So the project is called Temporal. I can describe it on very high level, like for people who are more technically inclined.
Sure, go ahead.
Yeah, so I think the idea is very simple, is that we preserve full state of code execution all the time. So what I mean by full state means that if you write code and it just executes, let's say you have a function, it calls a bunch of APIs and it's blocked on some API, and then process which holds this function crashes. So when reply comes, and reply can come 3 days later, we can resurrect that function in exactly the same state, still blocked on the same API call with all the variables, all the state there, and deliver the response. And then it will continue to the next line of code. So from the programmer point of view, this function never crashed. It just seamlessly waited for 3 days, blocked on that API call, and then continued execution. So practically you get crashless execution, right? Because we seamlessly migrated and seamlessly persist the state of the execution all the time. So from the programmer point of view, this function cannot crash. It just keeps running. So you can write a function which runs for a year, for example. And it's practical because, again, it's not linked to a specific machine, it's not linked to a specific process. It's always persisted. So it completely changes the way you think about reliable software.
Very interesting. Also, it sounds quite ambitious to me that it's possible for a zero crash. Like, honestly, it sounds so ambitious and you're doing it. And where do AI agents come into play here? What with the rise of these agents, what key reliability challenges do IT decision makers face and how does durable execution uniquely solve them?
So if you think about it, obviously we are very early in the whole agentic world and AI workflow space, but everybody is focused mostly around kind of when they say reliability, a lot of people hear reliability of AI giving good answers, which makes a lot of sense because this is where the most innovation happens right now. But what we found is that once you kind of pass this first phase, okay, now I have understanding how to use LLM and how use kind of stitch together APIs to produce some result for my business. Then you kind of next question is how do I actually make sure that this orchestration happens, right? And happens reliably and doesn't crash in the middle, or if some LLM call, for example, times out, or some tool takes long time. What do I do about all of that? And then the reality is there are not really any answers because all existing solutions, they think about reliable orchestration as an afterthought. And there is nothing there in the market which actually can guarantee completion of the process in especially in presence of all sorts of failures. Like there is no any product on the market which does that. And durable execution by its nature practically allows your code without many changes go and complete and continue executing. And as it's code, right, you just orchestrate normal code in top-level programming language, for example, Python. It means that it can be super dynamic. And this is how agents are different from workflows, right? Agents are very dynamic, right? They ask LLM what to do next, and then you execute tools, and then you can need to stitch all these calls together. And this is exactly a very perfect use case for the code. You can just take code and use it and implement any business logic, any super dynamic business logic. And durable execution is a perfect fit to run it reliably.
What happens in the case of a cyber attack? Can you still recover? Would it still be a zero crash? Like, how would that work?
So, okay, cyber attacks are very kind of different beasts because there are so many of them, right? But the main idea is that, at least the way it's implemented, is that mostly information stored in the durable execution is fully encrypted all the time. For example, there is open source version of Temporal where just architecture is, just to let's explain high level architecture, is that durable execution is part of your application. You just link it, it's a library which you link to your service and you deploy and you run your code, right? And then there is a backend cluster which keeps the state. It's kind of like database, or like you can think it's a cluster, or like similar to Kafka cluster, which keeps the state, keeps all the other things. And then your library just connects to that backend cluster. And that cluster you can run yourself. It's a MIT license open source, but you can also rely on our cloud. This is how we make money. And this is just exposes the gRPC interface of that cluster for you. The nice thing is that that code, when it uses any customer information, it always encrypts it, right? And this code, and you can encrypt it using your algorithm and keys, and you send it back to the backend cluster. And that backend cluster never sees it in clear text. So it means that, for example, if you use our cloud and our cloud is hacked, for example, which we never had I don't think we want to have it ever. But even if we go hostile, we cannot see your information because we never looked at the information. It's always encrypted. So practically the point is that even our cloud offering is compromised. Your information is never compromised. I think this is the most important part there. And then your workers, like your application itself, it certainly depends on what application is doing, what other data source your application is using. Then that information certainly can be compromised. But again, that is not something which is inherent to our architecture.
You can control what you can control, and you're doing it to the best of your ability, and that's amazing. You mentioned open source right there. How does Temporal's durable execution offer IT leaders this distinct advantage for building and innovating with AI beyond proprietary solutions?
I think the main thing is about first, Temporal is fully open source MIT license, and it's not kind of sometimes people do open core when we have this open source version which is not really doesn't have half of the features, right? And then they have this enterprise version. Our open source version is fully featured. It contains practically every feature we have, plus enterprise features like, for example, multi-region replication. It's in the open source. And also we guarantee compatibility. So for example, if you run code against an open source cluster, you can even do live migration to the cloud cluster without downtime. So we see it is very important to maintain full compatibility of proprietary part of our kind of and open source. And there are a lot of companies running at large scale with our open source solution still, right? So companies like Datadog, for example, they use it extensively on the backend and they fully run it on using open source version. So I think that is very important for us to maintain compatibility between those. And I think for the companies which use us, I think my personal opinion is if you're using any foundational technology, it should be open source because you never want to get into the vendor lock-in, right? And we also want the same thing because Temporal, because it's a new paradigm, you kind of need to write code differently. So your application becomes very dependent on this. You write much less code. You're much more effective, much more productive. But at the same time, certainly it's a lock-in into the technology. That's why we need to have fully featured open source just to make sure that you don't have risk of our company just doing something like in the future doing something which you are not going to like, right? That's why this open source is always there, and it's MIT license, so it's very like I don't think there are any other company doing MIT licensed open source right now and running big business. And I think we are doing that on purpose.
I was actually just going to ask you what makes you stand apart from other companies.
Yeah, okay. There are a lot of things make stand out. First thing is that we are practically the only like production ready large scale solution for which does durable execution. We were the first, and there are new companies which follow us there, but we were kind of for a long time we were just the only game in town at all for that durable execution concept. And people ask, what's your competition? And our competition always was practically build your own, right? Mm-hmm. Because what happens is people, when they need to provide reliability for their processes, they invent things. Like usually they just use event-driven architecture. So they use queues, they use databases, and these architectures end up being big messes. It's because events just run abstraction to build large-scale distributed systems. Besides this being practically standard in the industry, I think people quickly, slowly realizing that this is not the right way to do that. Problem is they didn't have an alternative. It was kind of given, okay, you either do RPC services or you go and switch to event-driven architecture with a bunch of queues. And right now we're practically giving an alternative when you can stay with normal service-oriented architecture with request reply, but every request reply can take 5 days if necessary and guaranteed to be delivered and completely changes the way you think about your systems. And going back to agents in AI, you think about what is AI application? It's, again, orchestration of a bunch of API calls, and some of them can take long time, and some of those flows can be very long running, and agents can be, especially these agents which are always running, right? Like they need to be durable, and they need to make sure that they complete and never fail. And this is exactly where we are very strong in those like durable agents which guarantee execution in presence of all sort of failures.
So you're also kind of saying that you do have like the quality of data that's uncomparable to others in that sense. That's why the training can take time.
Again, we are not data company, we are not AI company in the sense that we don't provide models. But the funny part about Temporal is that probably Temporal has more production use cases with AI and AI agents than probably a lot of other companies who have AI in their name, right? Because those companies focus on frameworks, right? They practically say, okay, we are AI framework for full. But building framework is not that complicated. Making this code run reliably at scale in presence of failures is extremely complicated. And I can claim that probably nobody can do it as good as well as we do. And that's why everyone who knows Temporal uses them for agents right away. Like every customer of Temporal comes to us and say, we built this agentic system, we built this inference system using Temporal because we know Temporal. Problem is that when people say AI, they don't consider Temporal as AI solution. They just use whatever is in the industry, like kind of is a standard, and then they need to work around all the limitations around reliable execution. So I certainly recommend people just look at Temporal every time you hear need to build AI agent system.
I also heard that OpenAI used you for its business logic code, if I'm not wrong.
So from things which, let's say we can talk publicly, the image generation. So every time you generate image using the OpenAI, it uses Temporal behind the scenes. Because image generation is orchestration, right? It's not just like one API call, right? There are a lot of API calls which need to happen to generate an image. And Temporal is a very good technology to guarantee execution. And then there is another product called Codec, which is, like this is practically a coding agent. It practically writes code for you, practically submits pull requests fully automatically. And that solution also uses Temporal for orchestrating their agents.
Okay. So if you had to use another use case, how would Temporal transform a developer's approach to these long running AI pipelines or critical business transactions?
I don't see AI being very different from the criticality point of view. It's just workflows are much more dynamic, right? Because if you use AI, a lot of these workflows are otherwise they're just, again, still business workflows, right? It doesn't matter if it's a human in the loop or AI in the loop, right? From the implementation point of view, it's still orchestration of some business logic. And Temporal been around for over 9 years, and the idea been around in the works for like much longer. And it's been used for driving large scale kind of, and again, large scale probably is I don't like saying large scale. It can do immense scale, but it gives you productivity advantage even if you're a startup with 2 people and you have small scale. It's not like some technology you want to use when you only get to the large scale. With Temporal, you want to start building your application with it because it will be more productive if you need resiliency. And yes, if you ever get to the size of OpenAI or like Snap, do you know that every Snapchat story is a temporal workflow?
Oh, okay.
Yeah.
That's
So
interesting.
yeah. So practically, we are not talking only about AI. We are talking about practically infrastructure automation. HashiCorp Cloud built around that, right? HashiCorp Cloud uses Temporal to orchestrate the like infrastructure. They use Terraform as an like from within that from Temporal, right? HashiCorp Cloud uses that as orchestrate the infrastructure. Datadog does the same thing. But then there are a lot of, for example, in AI and non-AI world, a lot of work happens in data manipulation, right? Practically data pipelines. So Temporal is used to practically build the whole solutions around data orchestration, data pipelines, the data processing. That is like very common. And then business processes, practically customer onboarding, payments, instant payments. Like for example, people in India use us for UPI to practically this instant payment solution. And then banks, like if you look at any bank is just a bunch of practically business processes. So we are very popular with banks to automate all these business processes. And then we have things like Snapchat, right? Like using Snap stories. So like all sort of like high level solutions, right? Like which Airbnb, every Airbnb uses that. Coinbase, like every Coinbase transaction is like uses Temporal. So practically every time you need to execute any business logic reliably, it fits very well. So we are not talking about AI. AI is just becoming right now much more prevalent and many more moving parts. And Temporal is very good with guaranteeing execution of all those moving parts.
Wow, I'm honestly amazed because when you mentioned India, Snapchat, the UPI system in India is one of the biggest in the world. Like they have gone online fully, more majorly than any other company. So you really captured the gap in the market, and it
Okay, we are
shows.
not running the whole UPS system because it's a huge India site.
Yeah.
We are talking about specific players and banks using that to do their side of the transaction, right? So and there is similar system. I don't remember the name in Brazil, right? So there are companies using Temporal for the same kind of instant payment system. And why would you use it like for no longer running? Because you need compensations, because you need guarantee of execution. And even if it fails immediately, you want to guarantee compensation because there are no transactions across services. So if you like any money transfer is a lot of API calls and something fails, you want to return error to the user, but then you need to roll back previous calls because there is no transactions across them. And this is where Temporal is used very extensively. So if you have synchronous sagas, again, look at Temporal.
So, looking ahead, what role will the open source community play in meeting the future of AI demands? And now I realize I have brought it back to AI. So, if you think there's something that is important to get out there, especially for the open source community, what would it be?
Again, because I think AI becomes practically all these AI solutions, we are going to build a lot of AI applications, and we will have to need to build a lot of infrastructure to run those AI applications and build those AI applications. And the reality is that, as I said before, unless a solution is open source, you as a company really cannot rely on it, right, for the long term, because practically you don't want to get vendor lock-in. You don't want to rely on something which later you don't have control, right? And unless it's open source, and again, obviously any successful open source ideally has some monetization and company behind them because that company will guarantee that this open source is improving. But at the same time, it should be real open source with a real open source license like MIT, Apache, or similar. And then it means that this company cannot really in the future, like, because again, nobody can guarantee what happens to a company, right? We can make all sort of promises, but companies are companies, they have their own life. So having real open source allows you to practically have the security that if something goes wrong, you always can take and use it yourself or rely on some other third party to take that open source, like we certainly saw it with Amazon doing for some other technologies and run with it. So I think open source is super important for practically any foundational technology, and AI requires a lot of foundational technologies.
If you had to summarize one key takeaway in 60 seconds from our conversation today for CIOs or IT decision makers out there, what would it be and why?
For me, is yes, open source is important, right? Just if your solution is not open source, think very, very hard, like what's your exit strategy. Second is that please give, like, look at temporal.io, give it to your architects and technical people to just understand what it is and what is durable execution, and and then think how it applies to your business processes, and think about developer productivity improvements you will get. I said they're immense. And then if you're doing any AI-based application, especially if this application goes beyond, you cannot just return errors randomly and drop data, then consider temporal for that, right? Just look at, then we have a lot of material about that. We have videos, we have tutorials. And if you're building agents, if you believe that existing frameworks solve your problem, look hard and check that, because in reality they are not. And yeah, that is probably would be a very, very short summary.
Thank you so much, Max, for joining us today. I really appreciate you coming on the podcast. Also, thank you to everyone listening. We hope you took a lot away from today's episode. For further information on what we've talked about, please head on over to temporal.io. We'll be back next week with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our socials at EM360 Tech on X and LinkedIn. And for more great daily content, please head on over to em360tech.com. Thank you so much.